Here's another example where we have two fractions with different denominators. And we proceed as before. We apply the fundamental fact about equivalent fractions and in the following manner. 2 over 7, I replace it by an equivalent fraction. And fundamental fact tells you, you may multiply the numerator and denominator by any by the same non-zero whole number. And as before, we pick the denominator of the other guy, 10 for the same non-zero whole number. And for this one, 3 over 10, we replace it by an equivalent fraction. The fundamental fact about equivalent fractions tells us we may pick any non-zero whole number, the same one, we can put it here and here. And we pick 7, 7, and 7. What does that give us? Then we have 20 over 70 plus 21 over 70. So we replace 2 over 7 by its equivalent fraction, 20 over 70. We replace 3 over 10 by its equivalent fraction, 21 over 70. So why is this sum a better one? Because now we have to add 20 copies of 1 over 70 and 21 copies of 1 over 70. These are fractions with the same denominator. And by applying the algorithm we have, we get a fraction with the same denominator. Numerator is simply adding the numerators. Here, we can simply add the numerators because the same denominator is telling us we have things of the same type, short segments of the same length. Here 20 of them, here 21 of them. Put them together, add them all up, just count it. So that's 20 and 21, added together is 41. And that's how we get it. Okay, so we've done a couple of examples with this same logic. Now, every problem I give you is going to proceed the same way, where if you notice the denominators are different, all you're going to do is you're going to say, okay, replace the first fraction by an equivalent fraction. The way you do it is apply FFEF, and the number you pick here will always be this denominator. And for this guy, the number you choose to multiply numerator and denominator, the same non-zero whole number, will always be the denominator of this guy. So we can summarize that using letters. So let's discuss this. So here I have, suppose A, B, C, D are whole numbers, and B is not equal to 0, D is not equal to 0. So what do I have here? A over B, a fraction, plus C over D, another fraction. Okay, just like this, but here we have now, by using letters, we give ourselves more freedom. If A could be 2, B could be 7, C could be 3, D could be 10, then we get exactly the same problem. But you could pick any other whole numbers for A, B, C, D, and then that means whatever we write out here also applies to another example. So let's see how we might proceed. Exactly the same way. We notice the two fractions have a different denominator. What do? We know how to add fractions with the same denominator, but we don't have that situation. So we go ahead and create for ourselves an equivalent fraction for A over B, another equivalent fraction for C over D, in such a way that the denominators exactly match up. How do we do that? We imitate this process. This one tells you A over B is replaced by A over B, and then they multiply the top and bottom by, do you guys remember what we did here? Where did we get the 10 from? From here. So here, what do you think we're going to pick? You're right. We're going to pick D. There. Similarly, C and D, C over D, we multiply numerator and denominator. We can do so if F says by the same non-zero whole number. What are we going to pick? Let's look here. 3 over 10 times 7, 7. Where did we get 7? 7 is the other guy's denominator. So here, C over D, we pick the other guy's denominator, B and B. Now notice what do we have? Same denominator, B times D, D times B, but you know, by the commutative law of multiplication, B times D is same as D times B. So no problem. What does that give us? That gives you, let me write it here. same denominator. So I'll write the denominator as b times d. What's in the numerator? A times d. I'll put a parenthesis to keep it clean, plus this number, which is c times b. So it's easiest if we can remember a over b plus c over d is this particular expression. What is this expression? How is it related to this? B times d is just these two numbers multiplied together. And and then in the numerator I have a plus sign. On the left side I have a times d. And then add it to c times b. That's what I have.